Historical archives contain invaluable records of people, migration, labor, and social history. However, many collections remain difficult to digitize and analyze. In this demo, we present ArchiveMind, an evidence-aware workbench that combines multimodal large language models, external knowledge sources, and human expertise to support the reconstruction and exploration of historical archives. Consider a typical historical record, such as this colonial-era migration pass document. The document is faded, handwritten, partially damaged, and contains historical spellings that no longer exist today. More importantly, there is often no authoritative answer available. Different AI systems may produce different interpretations, and historians still need to determine which reading is most plausible. The challenge is therefore not simply recognizing text, it is reconstructing trustworthy historical knowledge from uncertain and incomplete evidence. We adopted a human-in-the-loop workflow. First, ArchiveMind uses multiple large language models to independently read the same document. It compares their interpretations and identifies agreements, conflicts, and uncertainty. Next, uncertain views are routed for human review and can be validated using external knowledge. Throughout this process, the system preserves evidence, provenance, and review decisions. Finally, reconstructed information can be explored through interactive visualizations and analytics that connect people, places, shapes, and migration histories. The key idea is simple. Outputs are treated as evidence, not authoritative answers. Now let's see ArchiveMind in action. We begin by logging to the system and selecting the archival images we want to analyze. Once the images are uploaded, we simply click Run. ArchiveMind then sends each image to two independent large language models, which generate their own field-level interpretations and then compare those outputs and produce a reconstructed record. The first key idea is multiple independent interpretations. Rather than relying on a single model, ArchiveMind compares evidence from multiple sources. Here, the Results tab presents the reconstructed record, showing both confirmed fields and fields that require human review. Users can also inspect the individual outputs generated by GTP and Gemini. For each field, ArchiveMind provides an evidence trail, showing where the models agree, where they disagree, and why a review decision may be required. Users can also crop regions of interest from the original document and save them as supporting evidence. The second key idea is that human judgment remains part of the reconstruction process. In the review editor, uncertain views are automatically prioritized for review, while high-confidence views are provisionally accepted. Experts can add their own interpretations and annotations, which are recorded together with the reviewer information and timestamps. These decisions are then propagated back to the reconstructed record. ArchiveMind also supports collection-level management. Users can review multiple records together, save the progress, and export final results for further analysis. The third key idea is that uncertainty is preserved rather than hidden. The Analytics tab provides an overview of agreement patterns, review workload, validation outcomes, and other reconstruction statistics across the collection. These analytics help users understand both the extracted information and the confidence behind it. Finally, the Visualization tab transforms reconstructed information into interactive knowledge views. Users can explore where people came from, examine relationships between people, places, shapes, and discover migration patterns within the archive. Together, ArchiveMind combines multimodal AI, external validation, and human expertise to support evidence-aware reconstruction and knowledge exploration of historical archives. Thank you for watching.